So today, basically, yeah, it's a day 5, and we're basically going to talk about Near protocol basics. So today, we're basically going to apply our skills in writing smart contracts. But before we head there, we're just going to first establish your environment and get everything ready, and see, look at an example of a smart contract in Rust, and then we'll proceed from there. So, like I said, you ought to have identified your demo project ideas and be ready to start working on them as you proceed as well. Now, here are the tools you're going to be needed to have for this particular session. Initially, we've been having the first two, that is Rust and Cargo. Now, I've added some other 3, which you're going to see how we can install within our machines. The first one is the Webassembly the Webassembly package. This is basically going to help us compile our Rust source code. So we're going to have that package, the Webassembly package. We're going to install Near CLI, and we're going to create a TestNet wallet account. Now, for us to do anything on the Near protocol blockchain, we're going to need to have a wallet address, and that is where you're going to that is what you're going to find by creating the TestNet wallet account. Here are some of the things you're going to cover today. Package installation, that is the first thing. We're going to create a TestNet account. We're going to log into a TestNet account from our terminal. That is for development purposes. We're also going to do a Near smart contract project setup. So we're basically going to set up a project we're going to work from to do or to develop our smart contracts. We're going to walk through the smart contract code base as well. That is the boilerplate that is going to come with it. So great. Now I'm just going to hop into my terminal. Great. I hope you guys can see the terminal. Let me have the font increased. Awesome. So here we are. Now from my terminal, like I said, we're going to need to install. Now let me just share these first before we do it from the terminal. I think that would be better. So here we are. Now, for any reference during these sessions that we're going to have now from today henceforth, if you need to do some research here and there, you can always follow that link. I've just shared it in the chat. That will take you to the documentation of the Near protocol blockchain. And there's a lot you guys can learn from this point. So you can have some time to go through the site. Now, what we're going to do, since we're working with Rust, under the external documentation sites, I'll just click on Rust SDK. That will open up a new tab on my browser and direct us to the relevant page right here. So here you realize now on getting started, the very first thing we need to do is install Rust and the WebAssembly toolchain. Now, this WebAssembly toolchain is what is going to help us compile our Rust source code down to the WebAssembly bytecode that we'll be deploying to the Near protocol blockchain. Now, here is the code. Again, I'll just share this link just in case you missed the procedure. So there it is in the chat. So back right here, here's what you will be required to run in your terminal or in your command line, this particular line of code. So you can simply come right here and copy it and go paste it in your terminal, and that will be it. Okay. Since you guys have Rust already installed in your machine, you may have to skip this portion. But if you don't have Rust yet, then just go ahead and run this in your terminal. Then afterwards, come right down here and copy that and paste it in your terminal and just execute that as well. So that is going to set up Rust if you don't have Rust yet. And then using Rust, you're going to be able to install this WebAssembly toolchain, which is really going to come in handy to compile down our source code, our Rust source code. Now let's head on now to our terminal. So that is exactly what you're going to do right here. Now, if you copied that by pasting it, now this is what I copied from the site and I've just pasted it. So if you don't have the WebAssembly toolchain, just click on enter, press on enter, and everything is going to happen. Now, I already have that with me, so I won't do that. I already have that toolchain with me. Now, the other thing we're going to need to do, if you guys don't have that, please do it. The other thing we're going to need to do is install the Near CLI. Now, Near CLI is an NPM or node package that is basically going to help us make the transactions to our smart contracts or the Near protocol blockchain. It's sort of wrapped around the Near API JS, a library I'll be talking about while we cover the web frontend, so giving a frontend to our smart contract. I'll cover it extensively at that point. But just to let you guys know, the Near CLI package that we're going to install makes use of Near API JS library in the background. So for us to be able to grab Near CLI, we'll need to use our npm package to install it. So if you do not have Node installed within your machine, I'll again advise you to grab that first before we can proceed, because or before you proceed with this, you can find if I can open a new tab right here, Node.js, sorry, download. So you can just go ahead and search for Node. Not this one. Have a look at this. Yeah, so you can simply follow the Node.js link and grab Node for in your machine, because you're going to need these handy with the operations you're going to do. So here is all the information you need for you to install that if you don't have Node installed in your machine. Now that is going to bring with itself npm package that should be installed by default. And back to my terminal, if once you have all that in place, you just need to do npm install. And in this case, we're going to install this globally, and whatever you're going to install is Near CLI. Okay, so once you do this, these should install Near CLI in your machine, or they should avail that Near CLI package in your machine. Now, I already have that again, so I'll just have that out. Then I'll do Near to actually verify that it is within my machine. By executing Near, there's a bunch of commands that are listed right here. So all these are commands that I can use to perform operations or to interact with the Near protocol blockchain. Now you realize the usage is very well stipulated up here. For you to use it, you first of all need to begin your command with the word Near, followed by command and the optional arguments that they come in. Now, again, I'm going to take us through how we can use this particular package, the Near CLI package that we just installed, to perform a number of operations when it comes to our smart contract development. Now, the very first thing I'm going to show us before we proceed with the Near CLI, let me just head back to the browser, is going to be creating a TestNet wallet address. Now a wallet address, think of it as your usual or your normal wallet. I know men understand this. Your wallet. So in your wallet, you can have money. In your wallet, you can have either dollars, shillings, naira, whatever currency you happen to possess, right? All that can be within your wallet. Your wallet can as well contain your identity card. It can contain your Visa card. It can contain your passports, okay? So all these are your credentials that you're basically storing in one place. Now, in blockchain, a wallet address is used to store what we refer to as fungible tokens. Fungible tokens are, in layman's term, money. Okay, so what you can use, what you use as money, currency, to be specific. Okay, so in Near protocol blockchain, its native token is referred to as Near. We also have, it also has its stable coin, which is USN. We'll be seeing all that in a bit. So all these are going to require your wallet for them to be able to store in. Okay. Now, like I said, your wallet can as well contain other non-currency assets, like your identity card, your passport. These are not currency, but then they are some very crucial assets to you. Now, the same thing when it comes to wallet in blockchain, it can be used to store what we refer to as NFTs. So your NFTs. NFTs are basically non-fungible tokens. So all these are going to need your wallet address for them to be stored. Now, as developers, you're going to need your wallet address when it comes to developing and testing your smart contract. So you're basically writing a software that is going to run on a blockchain network. You'll need your wallet address for you to be able to make the deployment and every other transactions related to the development and deployment of your smart contract, or your smart contract in any blockchain network you're going to use. Now, in this case, we're talking about the Near protocol blockchain, and I'll just head on to the link. Now, if you want to create a testnet account, you head on to wallet.testnet.near.org. I'll just paste that in the chat. It's quite mouthful. So that is the link. So once you follow that link, it should give you an interface where you'll be able to create your wallet address, your testnet wallet address in this case. Now, Near avails two major networks for its blockchain. One is the mainnet network. Maybe if I can show us that. I hope I have nothing to lose in that. So we have wallet.near.org. Wallet.near.org is the link you're going to follow to take you to the mainnet wallet address, or if you want to create to acquire a mainnet wallet address. Now, the difference between a mainnet wallet address and the testnet wallet address, you realize that the interfaces are just the same, but the main difference is the testnet wallet address is used for test purposes. Okay, so the currency or the tokens you're going to acquire in a testnet wallet address are just for test purposes. You can't use them in any real world application or to make any transaction, real transactions on a blockchain. They're just there to, give you some sort of walkthrough on how things are actually happening on blockchain. But the mainnet wallet address, here, this is where you're going to make a real transaction. So this one holds real money, okay? Whatever is in your mainnet wallet address holds real money. Whatever is in your testnet wallet address is just meant for test purposes. So I hope that is clear. Now, you realize that I already have some wallet addresses right here with me. So I'll just go ahead and take us through the process of creating one. So if you don't have one, I'm going to show us how we can acquire one. So now that I have some wallet addresses with me, it means that if I follow this link, it will basically show me my dashboard. But if you're doing this for the first time in your machine, then you're going to get quite a different interface, okay, with what you can see right now. But there are two main things you need to note within that interface: the import account and the create new account. Now, since we are all going to create a new account, I'm simply going to click on this button, create new account. And you realize that brings us at this point. So at this page, we're going to be needed to secure our wallet address or our account ID, okay? So it has to be a unique account ID, and we're going to use something we can remember, unlike the ugly address you can see on my top right over here. So we're going to use something that we can remember. So at least we got that. So we have C4 hyphen Sankore, and you realize that the extension is there by default. So it will be C4 hyphen Sankore.testnet. Okay. So this is the what it is going to use for the better part of this particular training. And down here, it's telling me you'll need some near tokens to perform transactions with your wallet. Now you can ignore that for now. So let's reserve this name for us or for ourselves, C4 hyphen Sankore.testnet. So I'm just going to click on reserve my account ID. Then you realize that I'm presented right here with the security method. Now, apparently it lists only two. Previously, it listed it listed three. So one was secure passphrase, ledger hardware. Then we had the email method. So email was basically meant for for convenience, but I think they're trying to make it. They're trying to give more focus on security. So that was scrapped off. So we're going to use the secure passphrase. If I click on continue, if you have a ledger hardware, you can as well choose to go with that. But I usually prefer that for mainnet account where you're going to hold real money. But if you're just doing this on testnet, passphrase can do it well. Now you realize that we have a passphrase over here. Now using this passphrase, anyone will be able to have access to this particular wallet address. Okay. So usually if you're creating a mainnet account or even your testnet account, but then you don't want, you want to keep it private to yourself. So ensure that this particular passphrase over here is private with you. Okay, don't show it to anyone, because anyone with these, the whatever words you can see numbered right here, as I've just selected, can get access to your account. Now, if you're not pleased with this, or you need to regenerate some other set of words, then you can simply click on generate new, and that is going to generate a new set of words. Okay, then I'll copy. So I'm going to paste this. Let me paste this somewhere first of all before we proceed. Let me have it pasted somewhere. Then let's click on continue. So if you click on continue, you're going to be, let me have this over here. You're going to be requested for a certain word or numbered word from the list that was presented to you. Now, according to my list, they are requesting for word number 12, and my word number 12 is land. So that is basically what I'm going to provide over there. Then click on verify and complete. If you provided the right word, then your account is going to be created successfully. If not, that process is going to fail. So let's wait and see what is going to happen right here. Oh, great. So it went ahead and created for us that, or secured that wallet address for us, C4 Sankore.testnet, and some default money or currency was deposited to our account. Now, this is just meant for use cases or for test purposes. It gave us 199 point some decimal number right there of near tokens. That is worth 845.78 US dollars. Yeah. So this is basically how your testnet wallet address looks like. Right here, we have balances, which is basically going to list all the currencies you have within your wallet. Then over here, you have collectibles. Now, collectibles are things like NFTs. So if you're in possession of any NFT, they are all going to be listed over here. So if you remember the analogy I just gave of your normal or your physical wallet, you now can be able to relate something with this dashboard or what's going on. Okay. So all the activities that are going to happen in your account, in this case, in your wallet address or in your wallet, is going to be listed over here. So all the activities, you signed these transactions, you sent these assets to this person or this wallet address, you received this from this particular address and all that. All the activities are going to be listed over here. So like the one we've just done, we basically created an account. So an access key was added. We created that account. We received these 200 Near from the TestNet. So that was sent to us out of the box. Then we also had an access key added to our account on creation. So we have all that in place with that. Sorry for that, guys. So so that is basically it with our wallet creation. I hope you guys have noted the steps we've taken. It's the easiest compared to acquiring a mainnet account, if I may say. So I'll just head on to our terminal. Let's head on to our terminal over here. Yes, Samson?
So I wanted to ask, is the Near wallet the same as a Binance account? Or
okay, Near
does
wallet.
it work the same? Yes.
Well, I'm not so sure because now in Binance, when you create account, does it ask for your password? Maybe you can help us establish that.
In the Binance, it uses email and phone number for the security.
Email and phone number. And are you given a wallet address, or you just create account using your email? So you go provide your email, then
Yes.
password, then login.
Yes. Then from your email and phone number, you're given a wallet address.
Okay.
It's not the same as your email and phone number, but there is a wallet address, so that at least you can recover your account.
Okay. And you use the passwords. Use passwords when it comes to accessing your wallet.
No.
Okay. Then in that case, I think they're similar. I'm asking that because one that I think I'm quite conversant with is MetaMask. So if you come across Ethereum in that case, so you've interacted with MetaMask in some way. So it's the same analogy in MetaMask that has been implemented over here. I've not interacted with Binance that much. That's why I'm quite unable to establish that. But if they give you your wallet address and you're in full possession of it, then in that case, I think it's relevant to to the wallet addresses in here. Okay.
Okay.
Yeah.
So that means that all of these, like Ethereum and Near, they are all just blockchain networks. All of them. There is.
Yeah, Ethereum is a blockchain network on its own. It's an independent blockchain network. Near is also an independent blockchain network. Blockchain is another independent blockchain network. And these are the kinds of Solana and all that. So they are all independent, but they make use of the same protocol or the blockchain technology. Okay.
Okay. Thank you.
Great. So we're going to proceed. So now that we've created or we've secured ourselves a wallet address, since we are developers, we're going to use this particular wallet address quite differently from what any other person would use it, because these other people would use it to, accept tokens and maybe send tokens and NFTs and all that. So in our case, we're going to use our wallet addresses to test or deploy our smart contracts, or the softwares you're going to write. Now, the very first thing we're going to be expected to do is be able to log into our wallet addresses or authenticate to our wallet addresses from our terminal. Okay, so that is basically going to avail some credentials locally within our machine that are going to, sign the transactions that we're going to make in the Near protocol blockchain. Now, here is the first command we're going to use the Near Cli command we're going to use. So we're going to log into our wallet address. So we're going to do near login, just like that, near login. So this one is basically going to redirect us, as it has highlighted over here, to a browser. So I'll just go ahead and share these as well. I think it's here. Yes. So this is where we were redirected to. And you realize that it is giving us some information right here. There's a request to connect to your wallet address. So here we are listed with some wallet addresses we already are in possession of. So like I said, I already have so I now have 4. I initially had 3 of them. But if you have 1, that is the only one that is going to be listed to you. So for now, I'll just go ahead and select c4-suncore.testnet. That is what we're going to use. Then click on next. And that is going to request for some permissions over here. It's telling us that connecting with c4-suncore.testnet is going to require full permission. So full permission is basically we're going to be able to, it's going to give us sort of admin rights to this particular, to make transactions to this particular wallet address. And all that has been listed over there. So you can always take your time and read keenly. So for now, I'll just click on connect. Then it is going to request me to key in the wallet address that I want to use. So I'll just do that. And immediately you provide something corresponding to what you selected, then this button will be enabled. So I'll just click on confirm, and that should connect my wallet address. That should avail the credentials or the authentication credentials locally within my machine. And again, I'm going to show us what just happened behind the scenes. So that is saying that you are logged in, and I can go ahead and close this window. So if I go back to my CLI, you realize that the process was successfully done. Okay. Now, what basically happened behind the scene is, and again, right here, I'm going to share my Explorer. So if we head on right here, I hope you can see that. Here is my, yes, someone's hand is up.
Yeah, I wanted to know, should we run that command from the root of our project or just globally?
No, you can just do it anywhere within your terminal.
Okay.
Anywhere you launch your terminal. Yeah.
Okay.
Great. So over here, I'm going to show some hidden libraries within my file system. So what that command basically did is it went ahead and created a hidden directory within our machine, which is going to contain all the credentials of the wallet addresses we logged into. So right here we have near credentials folder. It's basically a hidden folder. So if you click on it, all your credentials are going to be arranged based on the network the networks of your wallet address. So in this case, we are working from a TestNet network. That's why we have a TestNet folder over there. If we logged into a mainnet network or mainnet wallet address, then we'd have a mainnet folder as well somewhere. So let me just click on that TestNet, then locate C4 some code over here. So this JSON file basically holds all the credentials we need to perform the operations using our wallet address C4-Suncode. So this is what the login command basically put in place. So for today, I won't show us what the content of that file is. So now that we have all that in place, right? We have Near CLI in place, we have Webassembly toolchain, we have our wallet address in place. What is now remaining is us setting up a project. Okay, so how do we set up a project? I'll again head back to our browser over here and just show us this. Now, if you followed the link I just shared with you guys on this link, nearsdk.io, there's a command that we've been given over here to create a new project. And again, this is making use of Node.js. That's why I told you guys you really need that particular package hand in your machine. So I'll just go ahead and copy this. Then let's go back to our terminal over here. And I'll just paste this command right here. Now, ensure you paste this command from the root directory where you expect your project to be established. Okay, so you can't just run this anywhere. Otherwise, it will place your project somewhere you will not be able to remember. Now, we're doing npx create near app. If you're coming from a React development, you should be familiar with these, or React Native. So we do npx create near app. Then we specify the language that we want to use to write our smart contract. Now, initially I said Near avails 2 programming languages you can use to do your smart contracts. However, one is used or recommended for real world application or smart contracts that you expect to face a market. Okay, so we have WebAssembly and Rust. So in this case, we're using Rust, and Rust is the recommended one. So that's why we have the -- contract put to Rust. Now, these usually defaults, if you don't provide this parameter for this option, it will default to WebAssembly. But now that we're going to do our project or write our source code in Rust, we have to explicitly specify that. Then right here, we're going to specify the name of our project. Let me just do greeting. Let's name our smart contract, this project greeting. Then I'll just hit on enter. So this is basically going to give us or set up the project on our behalf. Need to install the following package to proceed. So I'll just press on yes. And that is going to basically set up that particular project behind the scene. So we're going to come back to that once it is done. For now, let's walk through some of the commands that our Near CLI came with, what you can actually use when it comes to smart contract development. Now, the very first one I showed us was Near login, right? Great. So the first one I showed us was Near login. Now we have quite a bunch of commands you can use. We can check the keys that our wallet address, that are linked to our wallet address, so the testnet. If you do near keys.testnet, all this is going to be displayed. So it gives you the key and the permission for using that key, what permission you have using that key. So apparently we have, we just have public keys with full access permission, but we can as well have what we call function access keys. Yeah, sort of keys that are specific, they have specific functionalities in your wallet address, so they can be used to sort of send money and all that. Now, the other command would be, now we're going to interact with the other commands as we deploy our smart contract, run some commands to invoke some functions in our smart contracts and all that. So what I'm showing you is basically some basic commands here and there, okay? So first of all is the near keys. Let me see if that was done. Yeah, we still have all that in place. So if I take us back to our browser, I'm just going to show us a list of all these commands right here. We'll come back when that guy is done. So, welcome to now. If we head on back right here, I'm just going to click on, should be on tools. Let me check. Yeah, so here are some of the commands you can run using the Near CLI in your terminal. So we apparently did near login and near keys. You can as well generate a key to your wallet address. So we have near generate key. You can add key, you can delete keys, you can create account, you can view the state of an account and all that. Okay. You can as well send tokens. Actually, you can still use that to send tokens. So most of these we're going to use. We're going to see how to use them as we proceed. But maybe one that we're going to need handy is this, the Near create account. And I'm going to show us how we can create a sub account to our wallet address, the one that we just created right now. Okay, so let's head on to our terminal and see how we can do that right here. So that guy is still going on. So I'm going to show us how we can create. Now, a sub account is basically an address that has an extension of your main wallet address. Okay, like the one we did, c4-sankore.testnet. Now, .testnet is I can say it's the parent account to all other accounts in the Near testnet blockchain. Now we're going to create another sub account, but this one is going to be a sub account to the wallet address that we just created. Now there are some rules or some things you need to note while doing a sub account. So first of all, we're going to use the Near, then the command create account, and the account that we're going to create is going to be, let's call it grit dot. Now, like I said, it has to take an extension of the main wallet address we are going to use. So the main wallet address you're going to use is c4-sankore.testnet, right? So that is our main account, and we have to explicitly specify this main account using these other parameters. So master account. So this is basically going to list our master account as C4 Sankore. Drop this down. Yes, Sankore.testnet. So I hope you guys have a clear vision of that. So Near create account. The account we want to create is grit.c4-sankore.testnet. And the master account in this case, which should be the extension to our sub account, is c4-sankore.testnet. Now, if I go ahead and click or press enter from my end, it is going to save the key to this directory. Again, I showed us where we find it under this network folder, and this is the JSON file that was created, and the account that was created was grit.c4 and all that. Now, if we go ahead and do near keys, then we pass in our sub account, in this case, grit.c4-sankore.testnet. Then you realize it's going to display to us the key that we have for us to make. It's actually a full access key that we can use to perform operations using that particular wallet address. Now, this sub account wallet address is independent on its own. Okay, it's very independent, so it is not relying on our main wallet address in any way, except for that extension. Okay, so let's see if this was done. Great. So this was done, and I'm told to cd into greeting, do yarn dev and all that. Yes, guys, actually, if you don't have yarn in your machine, it's also advised that you grab yarn. It makes life a bit easier for you as a developer. Now, my NPM version is a bit out of date. I'll just copy these and be able to update this. Great. But since we have this in place, I'll just cd into greeting. That is the folder. Then I'll just open up this in my code editor. So we're going to have a look at the folder structure or the project that was generated to us. We're going to see how things are arranged inside there. I can have this share trace. Great. So again, I'll draw your attention to the sidebar of this particular IDE. So right here we have these folders in place, the contract folder. Now in the contract folder, this is where we're going to put all our smart contract, all our smart contract source code in our contract folder. Then we have near dev folder. So this is basically to hold our credential wallet information. The node modules, this again for front-end development. And the SRC folder or the source folder is basically where we're going to avail our front-end assets. Okay. Now, this is this sort of the folder system that was generated when we ran npx create near app and specifying all that options to set up a new smart contract project. Now, since we are apparently focused on writing smart contracts, we'll really not give so much focus on these other folders, except for the contract folder. Like I said, this is the folder we're going to work from to write our smart contracts. Okay, so I'll just open up that folder, that exact folder, the contract folder in VS Code, so that we just eliminate the other views. We just be concentrated on that VS Code folder. So I've not deleted the other folders. I've just opened up the contract folder in the VS Code. So I'll just share that now. Which one was this? Yeah, should be this. Yes. So I hope you guys can see that. That is the folder I just saw. So you realize that now we are in the contract folder. If you can begin on my topmost folder opened up in the VS Code. Now inside this folder, we also have quite a bunch of files. Now, up to now, you are familiar with the target folder, right? I talked about this while you are doing Rust. And you're also familiar with the cargo.tml file, cargo.loc. I know we are not familiar with this cargo folder, the .cargo folder over there. Then our resource folder or our res folders. This is where we're going to have our the bytecode copied into. Now, like I said, when you build your Rust project, the bytecode is going to be available somewhere within this target folder. But for, to make work easier, there's a command that we're going to use to help us copy that particular bytecode file into this directory, res. And inside our source folder, the SRC folder, this is where we're going to have all our source code go into. Again, I hope you're familiar with this because we interacted with this while doing the Rust, taking the introduction to Rust sessions. Now, within our source folder, we only have yes, done.
Sorry, I wanted to find out what is the res folder for, RES.
Okay, you're going to see how we're going to make use of it. Like I said, while we were building our Rust projects, our bytecode was being put inside this target /debug somewhere within this debug directory, right?
Yeah. Okay.
So now there's a command we're going to use, which is going to basically copy it from inside here to this particular directory up here for us to easily find it while deploying it on the Near protocol blockchain, other than having to dig it from these directories inside here. Okay.
Okay.
So it's basically going to hold a bytecode of our project, if I may put it short. And again, we're going to see how that is going to be done as we proceed. Now, guys, this is our main file. in our smart contract project. If you can very well remember, while we were taking the Rust sessions, we had the main.rs file, which was basically our main file or our entry file into that particular binary program. Now, in this case, while doing smart contracts that are going to run on the Near Protocol blockchain, the project is configured in such a way that what you're going to do is going to be a Rust library. I said there are two kind of projects you can do in Rust. One was a binary project, that is the main project, so the main program, or it could be a library that will be imported or will be made use of in another main program somewhere for it to be invoked, okay? So in this case, we're making use of a library, or we are writing a library that we're going to deploy, we're going to build, or in this case, compile to a bytecode, then deploy on the Near Protocol blockchain network. That's why instead of having main.rs right here, we have lib.rs. And on opening that, I really hope you guys can see the font quite clearly. On opening that up, we have a boilerplate code that has been put in place for us that can guide us, basically guide us through how a smart contract really appears or looks like on the Near Protocol blockchain. So we're going to walk through this particular smart contract and basically see, based on what we've covered in Rust, we'll be able to see how things are unfolding in this particular file, okay? It's just one file. So we first of all have some comments coming first over there. You can always take your time and read through all that. Then we have importation coming from line 15 to line 19. So first of all, we're importing Bosch deserialized library, Bosch serialized packages. So we're doing all that from Bosch. We also bring in near bingen macro and set up alloc function. Yeah, that's also a macro. Then you're also bringing in lookup. Now, lookup map is a data structure, but then we are pulling this from the Near SDK library. We are not pulling it from the standard library, Rust standard libraries. So really take good note of this, the kind of lookup map we are making use of. So lookup map is basically going to act as our database or our persistent storage on the Near Protocol blockchain. So anything that we are going to store inside the lookup map data structure is going to be persistent on the blockchain, okay? So that one is basically going to act as our database. Just take note of that. Then right here, let me just highlight from line 25 to line 27, we are declaring a structure. Now we covered structure previously, that should be last week. And we said this is how we do what? We declare structure. However, there are some things that have been added to our structure to basically qualify it or to be able to run it on the Near Protocol blockchain. Now that comes in line 23 and line 24, okay? So I'll explain what they do. Now first, then line 23, the near bingen decorator, or macro, sorry, macro. This one is basically going to help us serialize and deserialize our object. So in this case, our structure for the Near Protocol blockchain, okay? So basically, we'll be able to store the instance of our welcome structure in the state of our blockchain, okay? So we'll not have to sort of reinitialize it when someone runs it again, when someone runs our smart contract again, okay? It will only be initialized once on the blockchain. So this macro is basically what is going to help us achieve that. achieve that on the blockchain. Then these other macros, the Bosch serialize and Bosch deserialize, are like mechanisms we are using to do the serialization and deserialization. Now, we have JSON serialization and deserialization, and we also have Bosch. Now, Bosch is a mechanism that is a bit faster and lighter, if I may put it. Okay, so that is what comes by default, or what we can use by default. So these are basically going to help us serialize and deserialize our structure. Now, within our structure, we have a property or an instance variable, in this case, records. And records is going to be of type lookup map, which is going to store a string. Okay, sorry. It is basically going to store a string under a key of type string as well. Okay, so the first string data type in our lookup map is the type of key we are going to use, and the second string type in our lookup map is the type of data we are going to store under that key. I also hope that is very clear. Now, from line 29 to line 35 over here, we are basically doing a default a default initialization of our structure. Like I said, our structure on blockchain is only going to be initialized once. And by initialization, I mean, you remember when, you guys, you remember when we were doing something like this? So let's say we had welcome, then we were doing welcome, then we provide the properties, in this case, records, and we do all that, okay? So this particular line on blockchain is going to be executed once in the lifetime of our smart contract. It will never be redone again. So what will be happening is the state of our structure will be fetched and be executed from where it was previously, or from what it previously was. Okay, so from line 29 to line 34 is, sorry, line 35 is helping us give some default implementation of that if we are not going to explicitly capture it within our program. Okay, so again, this operation can be explicitly captured within our implementation of our structure. I'll be showing us how. So when we start talking about fungible tokens, we're going to see how all that unfold. But for now, within our default implementation, we're basically doing as an object. So we're basically creating a welcome structure, an object from the welcome structure, providing the property, in this case, the records, and initializing the lookup map. Okay, now again, take keen note on how we are initializing the lookup map. Okay, we are doing lookup map double full colon, then new. Okay, if you can remember, I said new is basically a function that is going to help us get derive a method out of a structure. So the new function is accepting a byte, and this byte is basically something that is going to help uniquely identify our records. Now you realize I said that our lookup map, so in this case, the records property is where we are going to store our data, or rather it's going to act as our database. Now, for the Near protocol blockchain to uniquely identify this particular blockchain of ours, we sort of need to give it some unique keys. Okay, unique, because we can have another lookup map. Let me just do this down here. We can have another lookup map saying names. Okay, so in this particular names database, it is still going to utilize the lookup map data structure. However, it is going to store a different set of data. So if we wanted to uniquely identify these two or even more lookup maps that our smart contract makes use of, then you need to provide different keys over here. So in this case, let me just undo this for now. Yeah, so in this case, these are basically going to uniquely identify these records lookup map. So we are giving it a unique character A, and then we are basically converting this to a byte string, then to a vector. Okay, so again, really take key note of that. Now, in our welcome implementation, or where we are actually providing some methods to our welcome structure over here, we only have two methods, if you can be keen. Okay, so we have the set greeting method and we have the get greeting method. Let me just minimize the get greeting method for now, and the tests. Okay, so let me draw your attention to the first method, that is from line 39 to line 46, the set greeting method. It is a method. It is accepting the self object, a mutable self object, and a message. So it has a parameter message, which is of type string. Okay, now the very first thing we are doing in line 40 is we are trying to check the wallet address that is signing this transaction on blockchain or in our smart contract code. Okay, again, I'll be talking quite elaboratively on the ENV module tomorrow or in our following session, so don't be worried about that. But if you wanted to know whoever is trying to sign this transaction in your smart contract, so in this case, the wallet address that is initiating this transaction, then this is one of the criteria you can use to achieve that. ENV : signer account ID as a method. So that will basically give you the wallet address that is signing this transaction. So we are storing that value inside the account ID variable. Let's move on to line 43. In line 43, we are again using the env module, performing or rather invoking the log function, and we are basically we are trying to print something in the terminal, and is going to be saving greeting. Then we pass the message in the greeting in this placeholder. For account, then we pass the account ID in the second placeholder. So this one is going to be printed in the terminal, guys. So again, we'll be seeing how that is going to appear. Then in line 45, we are through the self object, so the this object in other languages like Java and JavaScript, we are accessing the records data structure. So this is the records lookup map, the records of type lookup map. What I said is going to act as our database. And here we are inserting our message. So the message that we are bringing in as a parameter over here, we are basically inserting it into our database under the key account ID. Okay, so we are storing this message, and so it's like let's say I was signing this transaction using my wallet address. It means that the message I'm going to pass in is going to be stored under my wallet address, and if someone else comes with their wallet address as well and signs that transaction using their wallet address, it means the message they're going to pass is going to be stored under their wallet addresses. Okay, so again, I really hope that is home. So that is basically it about the set greeting function. It is basically storing a message in our smart contract. Okay, what if we want to view the messages we've stored, or the message that we just stored initially using the set greeting function? How can we do that, or how can we go about that? That is where the get greeting method comes in. That is from line 51 to line 56. Yes. So let's again go through what the get greeting is trying to do. Now, the get greeting is also a method. It's taking the self object, an immutable self object. So take the not the difference. So here we were taking a mutable self, That's why we were able to do self.records.insert, because insert is basically trying to change the state of our records variable. But right down here, we are not changing the state. So in this case, we are just reading the state of our blockchain, if I may put it so. So since we are reading the state, we don't need to take a mutable self. We only need to pass our account ID as a parameter. So in this case, the wallet address that contains the message we want, that is what we are basically going to pass as the parameter, the account ID. Okay, it is going to come in as a string. Now, once we have this account ID, we're basically going to access our records, okay, our database, if you can remember. So we're going to do self.records.get, and we are going to get the message under the key account ID that has just been passed. Okay, so this is what is going to this is what we're going to use to access the message. So the message was stored under this account ID. Okay, that is going to return to us an optional object, which is going to contain the message that it was stored under that particular key. Now, there's this an enum that we are making use at this point, guys. It's an enumeration object. We talked about enums the other day, and I said there's one that will really make use of quite popularly when it comes to smart contract writing. So I'll be exploring that in a bit. But this is an option. An option has two members, if I may say. So the first one is sum, which is kind of function. It takes the function, comes like a function signature. Then the none. None simply means there's nothing, or null in JavaScript. Okay. So if whatever was returned had some value, then that is going to be captured in our first case. So we're going to do sum, then the value that was returned is going to be under this greeting variable. And if nothing was returned, then it will be none. So that will take us to the second case. And since there's nothing, we're simply going to return hello. Okay, so toString is basically converting the string literal hello to this type string with capital S. Now, if we found the message, then we're basically going to return the message as it is. So in this case, greeting. Okay, so that is basically what is going on at that point. I don't know if there's any question up to that point from anyone when it comes to understanding our smart contract. Because what we're going to do right now is we're going to deploy it on blockchain and basically see how things are unfolding, or how we can be able to run this particular program on the Near blockchain. So if there's any question, maybe you can just put up your hand as we do this. So yes, Dan.
Yeah, how do we get the user ID from the user?
The user ID. So in this case, you're talking about the wallet address?
Yes, the wallet address. Like if we are running on this lib file, how do we get it and add it to this lib file? Do we get it from the front end, and then do we just put that in there? Yes.
Oh, we're actually going to see as we run the program. So okay, while we invoke the set greeting function, and maybe something, guys, you need also to realize these are public functions. For us to be able to run them, they have to be public. Okay, I think I never mentioned that, but please take good note of that. So while we're going to run the set greeting function, we need to sign this transaction, and by signing, I'll show us what is expected of us to do for us to for it to qualify as a signed transaction. Okay, Dan?
Okay,
yes.
Okay.
So that is where we're going to see how we actually pass the wallet address that we are going to accept or get using this particular function over here. Yeah, so let's move on. I'll just bring back my sidebar. Then I'm going to create another folder, or I'm going to put another folder in place that is basically going to help us perform these operations or these commands quite faster. Okay. I'm going to do a script folder. Great. So I just added a folder, the scripts folder. So this is the folder that is going to help us run the very many commands we are going to run for us to be able to, deploy our smart contract and run or invoke our smart contract functions. So in this in this folder, the script folder, I have a setting.conf file. So this is basically a config file for our scripts file, our script files. So in our config file, we're going to capture a master account and a sub account. Now, the master account or the master wallet address we are going to use for this particular operation is going to be the one that we just created, c4sankore.testnet. Then the sub account we created out of that was grit.c4-sankore.testnet, right? So I'm basically bringing in c4-sankore.testnet using this variable. Now, if you've done script files, I know this is going to be a breeze to you, but for those of us who've not, just know that this is how we do it. This is the variable, and for me to be able to capture a value or to get a value under this variable, I need to add a dollar symbol before the variable name. So that way I'll be referencing to the value that is actually stored under that particular variable in our script. So this will basically generate grit.c4-sankore.testnet. Okay, I hope that is clear. So to our build script, we are doing cargo build. I know we are familiar with the first part of our command up to that point, but then you realize that there's quite a bunch of other things that this command that is accompanying this particular command. Okay, so this is where the WebAssembly toolchain comes in. So we have all these flag, and you are saying that, hey, instead of the normal bytecode generated while you do cargo build for Rust projects or for Rust programs, in this case, we are specifying the target bytecode or the target file we need. So in this case, we expect cargo build to compile our source code to a WebAssembly bytecode. So that is where this package comes in. And again, if you key this, we installed it. So basically compile our source code into WebAssembly, then do a release version of that. Okay. Now, like I said, that by default is going to be stored under the target directory right here. So you realize that this path is quite a bit long, or it's quite deep, if I may put it. So for us to be able to easily access our bytecode, we are basically going to copy it. So CP is meant to copy this bytecode under this path to this directory, the resource directory. So after doing our build, and again done, if I may come back to your question, our bytecode is going to be copied to this folder from a folder under target. Okay, so let's just go ahead and run this and see how this is basically going to unfold. So I'll be pushing this to GitHub, so don't worry about memorizing all these commands at a go. Okay, so I'll push this. You'll get all these scripts with you at the end of this particular session. Now, I said these are scripts files. I'm on Linux, guys. Maybe I should just put that clear. If you're on Windows and you want to run our script files, following the steps that I'm going to use, ensure you select bash. So on my this sort of middle right, this menu over here, just after the plus, there's this drop down symbol. Select bash, and that is basically going to fire up a bash shell that you can now use to perform all these other operations. Now, the very first thing I'm going to use, I'm going to do is grant permission to my script files for them to be able to execute, because by default, my Ubuntu system doesn't allow them to be executed. So I'm just going to grant that permission. So I'm going to do chmod 755, then provide a path to my script files. So all the scripts, that is what I've specified using asterisk. Okay. So after doing that, all that was done quite successfully. And now I want to go ahead and run our build script. Now, by running our build script, I mean that instead of copying this command and pasting it in our terminal and running it, I just have it in a file. Then by executing that file, it will basically go ahead and execute this command in terminal on our behalf, other than us doing it manually. So I'll just go ahead and do scripts /build.sh. So that should go ahead and build our source code, the source code to our smart contract. And I want you to be keen on the rest. Let me also bring up this target folder. You realize that there's this other folder that has appeared just now. Inside it, we have a release folder as well. And inside the release folder, we're going to have our bytecode. So basically, the bytecode here is what is going to be copied to our res or resource folder up there. So let's just wait for this to sort of finish up. Doing it for the first time, I think it takes quite a while. Yes, Jerry?
Yeah, I was asking, what was the command that you've just written before it started compiling?
This one over here. Are you able to see what I've highlighted?
Yeah.
Yeah. So that is basically what was run for us to generate all these. Yes, Lawrence?
What about the command to run the script file where those building commands have been stored?
Oh, that command is up here. So, okay, you basically provide the path to your script file, okay? It was not really a command, but a path to your script file. So our script file was under scripts directory / the actual script that in this case we are trying to, sorry, there's some noise. In this case, the script you are trying to run, so build.sh. I don't know if that was clear, Lawrence.
Yes, it's now clear.
Okay, great. So great. So this is complete. So it finished building our project, sorry, our smart contract. So bytecode, and down here inside this folder release, we have greeter.webassembly. Then that was basically copied to our resource folder up here. So we really don't need to open our target folder anymore, because that is going to be done out of the box for us with this particular command over here. Now, this greeter name was taken from our cargo.tml file right here. Realize that we named our project greeting, right? We named it greeting, but then what is in our cargo is greeter. So this again came as default, but you can always change the name. If you change this, it will basically change the name for your bytecode. So again, there is no issue. Now that we have just compiled our source code to the WebAssembly bytecode, This is the object. You realize I'm unable to open it up in my terminal. So this is the bytecode file that we are going to deploy to the Near protocol blockchain as our smart contract. So this is what is going to now serve as a smart contract in the Near protocol blockchain. And we're also going to see how we can do that just in a bit. Now, just before we do that, let's head on to a script file that is going to help us basically achieve that. So the deploy.sh file. Now, inside here, now, guys, again, if you're interacting with script files for the first time, I know for those of us who are on Linux could have some experience with these, but before you write a script file, you need to put this statement in place. So line 1, take note of line 1. So you don't just go ahead and start writing your commands without this first line. Otherwise, Bash will not be able to really comprehend what you're trying to do. Okay. I saw a hand up. Yes, Destiny. Oh, Destiny, welcome.
Yeah, thank you, sir. Good evening, sir. From
Good evening.
Nigeria. You just did something in the command line, even on my command prompt. That's in the terminal. We're having that issue. I don't know how to exit a program while it's running. But I just close the whole window and
No,
start fresh again.
you can just do
So
Control C.
I'm getting tired of. You said?
I said you can just do Control C from your terminal. You should be able to terminate that process.
Okay, Control C.
Yeah.
Okay. Thank you, sir.
Great. So let's move on to the deploy script. Now, our deploy script, you realize that first of all, we are bringing in our variables that we defined in the settings.config file over here. So this is how we import it in script files. We do source, then the path to our source configuration, so to our configuration file, sorry, like that. Then from there, we now do our commands. And the very first thing we are doing in this case is at this point, we are deleting a sub account, but we are not going to delete a sub account for now. I'll tell us why. Because we've not yet deployed any contract to our sub account or to the account we are going to deploy our smart contract to. So there's really no reason for us to delete it. Okay. And we also created the sub account we're going to use to deploy this particular smart contract initially while I was taking us through the command line, the Near Cli commands, right? So there's no need of creating it again because it's already in place. So that's why we again will not be executing line 7. But we are going to deploy our smart contract now in line 9 to our sub account, because now that our sub account is in place, we are going to deploy our smart contract, and in this case, the greeter.wasm file, so greeter WebAssembly file. So we just need to provide that path to this particular parameter. So you realize we're doing near deploy. This is the command, near deploy. Then we provide the sub account. This is a wallet address as captured here. It's basically a wallet address that we created initially, greet.c4-sanctuary.testnet. So we do near deploy, then provide the wallet address where we are going to deploy our smart contract. And a wallet address, something to note, a wallet address can only contain one smart contract in it. So you can only deploy one smart contract to a wallet address. So the ratio is 1:1. Okay, you can't have several smart contracts deployed under one wallet address. That won't work. Then right here we provide this parameter wasm file. So wasm file basically expects you to provide the file path where you have your WebAssembly bytecode in. So in this case, we are doing resource greeter. Let me just change this. This should be greeter.wasm file, okay? Because this is what we basically want to deploy to the Near protocol blockchain. That is the bytecode. Awesome. So let's go ahead and run, execute this script in our terminal for us to be able to deploy this to blockchain. So again, in our script file, we're only going to run this command, okay? So I'll just go ahead and provide deploy script file right there and run that. And let's wait to see what this is going to give us. So it's starting deployment to the account ID greet.c4-sankore.testnet. And yeah, it was done deploying to this particular wallet address. So it means that our software or our smart contract is now already on the testnet, on the Near protocol testnet network or test network. Okay, so it's already on chain. Anyone using testnet can basically be able to run it or interact with it. Okay, but how do we exactly interact with that particular smart contract on the blockchain? Now, if you already acquired the testnet wallet address and you've installed Near CLI in your machine as we speak right now, you should be able to perform the commands we are going to do next, and you should be able to get relevant results from your end. That way you'll be interacting with a smart contract that you just deployed right now. Okay, so let me just again close this for now, and let's head on to the call script. So in the call script, this is where we are going to call the functions. Let me just do away with the content we have right here for now. Do away with all that, and let's begin afresh. So the first thing we're going to do is we're going to add message, right? What did I do over here? So we're going to add message. Then the second thing we're going to do is get that message that we just added. Okay. So these are the two main operations or two main ways we're going to interact with our smart contract. These are comments. That is how you write comments in a script file. Now, for us to be able to add message to our smart contract, we're going to have to invoke the set greeting method. So this method over here, this is what we're basically going to invoke from our terminal. However, this time around, we're not going to run this program in our machine. Okay, guys? So usually or previously, when we were doing Rust programs, we could do cargo run and things would just work out of the box, right? Or it would basically go ahead and run our program by doing cargo run. Now, in this case, we don't do cargo run because this software is not locally within our machine. It is in the blockchain, in the test network near protocol blockchain. So for us to be able to run our set greeting function, then we'll have, this is how we go about it. First of all, it is a function that expects us to sign it because of the use of the env module. I'll be talking about that tomorrow, so don't be worried about how to identify all that. So I'll just do near call. So near call is the command. Then I'm going to specify the wallet address where our smart contract was deployed to, and that is the sub account. Okay, so this is where we deployed our smart contract. So this is where our smart contract lives in the Near protocol blockchain as it is right now. So I just specified that. Then the next thing I need to specify is the name of the function I want to invoke in our smart contract. Okay, so the first two is the command. The next one is the account or the wallet address where our smart contract lives. The third one, this one, is the name of the function we are trying to invoke in our smart contract. And this function must be available within our smart contract or within the implementation of our main structure in our smart contract. So we realize we have only two functions for now, the set greeting and the get greeting. Now, since we are going to invoke the set greeting function in our smart contract, it requires us to provide a parameter called message. So in other words, it requires us to pass some parameter to our function. Okay, so again, we're going to provide this message as a parameter to our function, and take note how we are going to achieve this. Okay, we're not going to do it as we've been doing it with the normal Rust program. In this case, for us to specify that, hey, for this parameter, give it this value in a smart contract or on the Near protocol blockchain. I first of all, we provide this in a JSON representation. And for me to be able to pass it in a JSON representation from my command, I do single quote, then comes the JSON object representation. Then I need to enclose in double quotes the parameter name, in this case, as it appears in your function signature, right here, message, okay? So I just went ahead and copied this to over here. So that will serve as the attribute to that, or key to that JSON object. Then I'm going to go ahead and provide a value to our message parameter. So this time around, the value to our message parameter is going to be our first test. So this is basically the message that we are going to store in our smart contract, our first test. And this one is going to be injected into our function through the message parameter. I really hope I'm not confusing you guys. If you're not getting anything, just please raise up your hand. Now, after we've done all that, and again, getting back to the question of done, how do we specify that this wallet address is signing this particular transaction? So this is how we capture that from our command line. Again, I'll be showing us how to do this from a web front end when we do front end. So don't be worried about that. So from our command line, we're basically going to specify the wallet address that is going to sign this particular transaction, and that is the one that we just created. So I'll do -account ID equal to C. So I think that was our master account, right? The C4 -samcore.testnet. That is basically our master account. So that is what I'm going to specify right here. So I just brought it in through the master account variable, and that is it. Yes, Lawrence.
It's
Yes.
account.
Sorry.
You've written something wrong. You've said account
okay.
ID.
Oh yeah, sure. Thank you. It should be account ID. Yeah. Thank you. Thank you for that. That is how it should appear. Now, up to that point, our command is complete. Our command that is going to add message is complete. So I just want us to go ahead and run or give it a try from our terminal. Okay. So here's the command we are going to run by invoking our call script. So again, I'll just go ahead and now invoke our call script from the command line. So you realize it's doing account.function call. So it's basically invoking our set greeting function. So that was successful. How do we know? Because it returned an empty string. Now, apparently in our set greeting function, we were not returning any value, right? So by default, if you perform this in your terminal, it will to denote or to tell you that everything went successfully, it will basically show an empty string after here if your function was not returning anything. So now that that was the case, it means that that worked perfectly in our smart contract. And now we have in our records database a message stored under our account ID, in this case, our wallet address that we just used. Now we're going to try to retrieve this message that we just stored within our records database in our smart contract. That is the command we're going to write next. So let's do this. In our call.sh file under the get message, this time around we are because we don't need to sign this transaction, so we don't need to by signing, I mean signing requires a wallet address, okay? And a function that does not need your wallet address to sign a transaction is referred to as a view function, okay? This other one that required our wallet address to sign this transaction is referred to as a change function. So a change function changes the state of blockchain. Like for instance, in our set greeting function, we are changing the state of the blockchain by adding our message to our records property of our welcome structure. Okay, so we are basically adding data to our smart contract. So it is changing the state of our smart contract. However, our get greeting function is really not adding any data to our smart contract. It is basically reading some data from our smart contract. So in that case, it is a view function. It is just reading data. Okay, so we will not, or rather, we don't need to sign a transaction invoking this particular method. So how do we represent that? We're going to use a near view command to achieve that. So we do near view. You realize for a change function, you do near call. For a view function, you do near view. But you still can use near call to call a view function. That should still work. But you can't use near view to call a change function. That one won't work. Take good note of that. So we do near view, then we follow it with the wallet address where our smart contract was deployed, in this case, the sub account. Then we specify the name of the function we want to invoke in our smart contract. This time around, it is the get greeting function, and that is what we specify next. The third or the other option we need to put in place is our function is accepting account ID parameter. So we need to give or provide some parameters to our function. So that is captured using this JSON representation. Then we provide the parameter name as captured in our function signature account ID. So you just copy that and paste it as it is over there. Separate that with a column, then provide a value that is going to be injected to your function through the parameter account ID. So in this case, the account ID we are trying to view, the message that we are trying to view was stored under account ID C4 sankore.testnet, right? So that is why we provided that. And now that this is a view function, or now that we don't need to sign this particular transaction, we don't need to specify this part. We don't need to specify any account ID signing this transaction, because these are view function. We don't have to sign it, okay? But we don't need to sign it. So this one is just going to be invoked as it is, okay? So I'll just go ahead and comment out our command in line 6 because we already executed that previously. So for now, we're just going to execute line 10, the command in line 10 for us to see, to be able to see the results. Now, even before I go ahead, maybe just something to mention, our get greeting function has an explicit return type, which is string. So we expect this function to return some string to us or return some string after invocation. And this string is particularly going to be displayed in our terminal, okay? So let's go ahead now and execute this in our terminal. So again, I'll just execute that by calling our call script. So basically passing a path to it. Then I hit on enter. And you realize that the string that has been returned to us is our first testnet, okay? This is what we initially stored by performing the command set greeting and passing our first test message to it. So this time around, we are trying to retrieve it, and it is exactly what has been returned to us. So all this is happening on blockchain. All this is happening on blockchain. And maybe just to prove that, I don't know, is there anyone who has installed Near CLI? Just Near CLI. You don't have to use the wallet address. I just need someone who has Near CLI installed. Dan, are you in a position to share?
Yes, yes, yes.
Okay, so let me just elevate you to a panelist. So you're going to join as a panelist, then you're going to share your screen. I hope you have the package installed, Near CLI package. Also, great. Now in your command line, I hope you have Near CLI, right? Yes, great. So just go ahead and do near view, just like that. Yes, near view, near view for view function space. Then the sub account where we deployed our smart contract. So in this case, greet.c4, just write that. Yes, so we have a near view. So near view is the command we're going to use to invoke our view function. Then the greet.c4 -sanctuary.testnet is the is the account ID where we deployed our smart contract. So in that case, the wallet address where we deployed our smart contract. Then get greeting is the function we are invoking in this case, okay? And like we said, our function accepts a parameter called account ID, and we are basically, or rather passing that as a JSON object with the account ID and C4 sanctuary.testnet as the value to it, okay? So that is how we do a view call to a smart contract. So just hit on enter. Let's see what is going to print for your end. Awesome. So you realize it prints our first test. That means that that software is not running on my machine, okay? That is being executed on the blockchain. So it's live on blockchain as we speak right now. Once you have Near CLI in place and everything, you can be able to interact with it like that. So thank you so much, Dan, for that. Yes, so we are back. We are back to my VS Code, and whatever you can see is what we've just proved from while Dan was sharing. You just exit that window for now. Now, up to that point, guys, I think we've covered what we were to cover. Sorry, for this session. We've seen how we can install WebAssembly toolchain. We've seen how we can install Near CLI package using the Node of the Node package. Then we've seen how to create a TestNet wallet address. We've seen how to create a sub account, right, to our wallet address. We've seen how to build a smart contract source code, in this case, a Rust source code to a WebAssembly bytecode. We've gone ahead and deployed the bytecode that was generated, this one, to the Near protocol test network blockchain. And we've gone ahead and seen how we can invoke the functions in our smart contract. So in this case, the set greeting and the get greeting of our smart contract. So that brings me to the end of this particular session. I don't know if is there anyone with any question or anything you think you've not well understood, where you might need some further clarifications? Yes, Lawrence.
You said that one smart contract per an account.
Yes.
How many sub accounts can the main account hold?
As many as you can afford. Now, there's a reason why I've put it that way. You see, and let me just respond to your question by taking us back to let me share the web interface of our wallet address. Let me just take us there. I don't know if I can find these. Oh, please don't. Yes, so here we go. Yes, we were here, right? So here is our testnet that we created, the C4 Sankoredo testnet. Then inside it, here are the recent activities. So I've not reloaded this page, guys. So really take note of this. I've not reloaded this page. So here are the activities that have been listed, but we've done quite a bunch of other activities after we created this account. So I'm just going to give it a refresh for it to be able to display to us some recent activities that has taken place. And also take note of the money or the currency, the tokens we had in our wallet. It was 199.9 something, right? So after reloading, you realize that our tokens have decreased. Our tokens we had 199, but we now have just 99. Where did the rest go to? That is what we're going to find out, and why. So the very first thing we're going to note over here is that after creating our account, so all that activity came while we were creating or setting up our account. We created a sub account right here. And while creating this sub account, 100 Near tokens was sent to it. That's why we have our balance less 100 tokens. So it means, Lawrence, while creating these sub accounts, you're going to need to fund them in a way, okay? So as long as you have funds to fund them, then you can create as many as you want. As many as you want. As long as they also have unique names or unique names. So you can't create Greek, you can't have Greek.c4 Sankore.testnet, then try to create another sub account with the same wallet signature, Greek.c4 hyphen Sankore. So they have to be unique. And as long as you have enough funds to fund all of them, then you're good to go. So by funding it, we were able to create a new account, which was great.c4 hyphen Sankore.testnet. So this was the sub account that we created, right? And you can view that in Explorer. I think I'll be talking about that as we proceed. Then we went ahead and called the set greeting method, or invoked the set greeting method in the smart contract we deployed in greet.c4 for this wallet address, right? So you realize that that is also captured under recent activities, okay? Because we signed this particular transaction using this wallet address, c4-sancore.testnet. This is the wallet address that we used to sign that transaction, and it was definitely captured in our activities. So that's why it is listed here. The method that was called was set greeting. It was called in a contract that was deployed under this wallet address at this time, and it succeeded. If it would have failed, then that would as well be captured. It would have been captured over here. Okay. Now this information will ever be there on blockchain. This record. Okay. So we can view that in Explorer. So Explorer is where you're going to get some more details of that particular transaction. So we are able to see how many gas we attached. So we attached 30 teragas. Again, I'll be talking about this as we proceed. But then we only used 5 teragas. So these are also tokens. This is why I was saying that every transaction you do on blockchain is sort of entails money, or you spend some money. So these are tokens that are being used. Okay. Then yeah, this was the signer. This is the receiver. The status was successful. Here are the arguments that were passed, message, our first test, and all that. So you basically use Explorer to find out or to get or view more information about your transaction. Okay. So yes, back to your question, Lawrence, you can create multiple sub accounts as long as you are able, or you're in a position to fund them.